We are live. Welcome everyone. This is our Sensors4Rail special live stream. My name is Frank. I'm part of the social media team at Here Technologies, and I'll be your host for today's stream. So if you've been following our channels, you might know that we're at ITS World Congress right now, and we are currently doing this broadcast both on LinkedIn and YouTube. So wherever you're connecting from, thank you very much for joining us. So we're in Hamburg today, and we want to share like a special experience that we're doing at ITS. So you might have heard about the Sensors4Rail project, and this is what we're going to be diving a little bit deeper today. But basically, there is this physical event, physical train that people can onboard, and we're going to tell you a little bit more about this. But during the stream, you will be able to see and experience everything that the train is experiencing. So while everybody on the ground will be, attending the train, and they will be with some of our here colleagues, then we'll be able to showcase this with you as well. So before we get started and before we talk about the Sensors4Rail project, I would like to introduce our two main speakers today, starting with my colleague, Thomas Robinek, who's Industry Solutions Manager at Here. How are you doing, Thomas?
Hi everyone, and thank you, Frank, for asking. I'm doing well. It's great to be here in Hamburg and to meet with our customers and partners face to face.
Oh, I think we might have some audio issue. Just one moment. Okay. Seems that it's all good now. So your counterpart today will be Ruben Schilling, lead perception at Touchban. Ruben, how is your ITS experience so far?
Oh, hi. Yeah, I'm Ruben, and experience is great. So we've received a lot of good feedback. We've received a lot of interest from all over the place, and I'm really happy to be here with you today.
Good. And so before the train starts, can you maybe tell us a little bit more about Sensors4Rail? What is it, and how is your involvement in this project?
Yeah, thanks. Sensors4Rail is a joint research and development project by Deutsche Bahn and our partners Siemens, Bosch, IBEO, and Here Technologies. And we started this in 2018. And today we want to show you the results of bringing perception and real-time localization technology in combination with a digital map to the railway, to mainline railway, I have to say. And we're really excited to present to you the results and show you how we can not just automate rides, as is in our sister project, but also automate the route observation.
So we'll be basically following a rail train, and this test train is already at the station. So in a few minutes, we'll be able to start with the live animation for the guests at ITS, but also for you in the live stream. But first, let me guide you through our schedule for today. So we'll start with a quick video that explains a bit about the project, the different stakeholders, and how the different companies are interacting as part of the Sensors4Rail project. So this should give you like a great overview as to what it actually is. And then we will start with the live demo. So everything that we'll be showing you today is not like pre-recorded. We're actually following a train, and we'll be seeing everything that the train sees and perceives. And our two experts today will be telling you a little bit more about everything that's behind the scene. We should have time for Q&A at the end. So if you have any questions, please feel free to put them in the LinkedIn chat, and we'll have a look. And in the meantime, just let us know where you're connecting from, because I know some of you might be in Hamburg, but some of you might be connecting from other places. So just let us know where you're connecting from. And if you have any question when it comes to rail or Sensors4Rail, feel free to add them during the stream, and we'll come back to them at the very end. So few minutes before the virtual ride with Sensors4Rail. And for now, we're just going to show you a quick video that briefly summarizes the project. And then we'll see you straight after. So sit back, relax, and imagine that you are with us at ITS.
Less traffic, less congestion, and fewer harmful emissions on the road. More passenger transport and freight traffic on the railway. The future of mobility is rail. The sector initiative Digitalization Deutschland creates more capacity, reliability, and efficiency for the railway system without building a single new track. The foundations for this are laid with the radical modernization and digitalization of infrastructure. On this basis, intelligent future technologies continuously get integrated in the rail system. A future project that Deutsche Bahn implements together with several industry partners as part of Digitalization Deutschland is Sensors4Rail. The goal, to equip trains with comprehensive sensor technology for environmental perception and real-time localization, enabling even tighter scheduling of trains. This enables higher utilization of the rail network. The challenge, the combination and integration of various technologies from completely different industry sectors in the rail system. 5 partners have joined forces to tackle this extensive research and development project. Deutsche Bahn provides the vehicle and the infrastructure. It also oversees system design, vehicle engineering, and conversion. Siemens leads the system tests and determines the highly accurate train front position using an advanced localization method that evaluates the motion data of the train. Bosch and Ibeo supply the sensors for environmental perception and object recognition and fuse the sensor and localization data using intelligent algorithms. And HERE creates a digital HD map in 3D using high-precision laser, enabling the accurate localization. In the first step, the train is equipped with extensive sensor technology. Cameras, radar, and lidar systems on the front of the train detect dynamic and static objects on and near the track. In the second step, a high-performance computer fuses the sensor data to provide a reliable image of the train's surroundings, even after dark or in fog. It also recognizes the course of the tracks and puts it into context with current driving conditions and objects in its vicinity. In addition, it is possible to detect the position of the train relative to landmarks such as catenary poles, platform edges, or buildings near the track, and use them as a reference for the location of the train. This information is compared with the landmarks saved on the HD map and with the position detected by the Global Navigation Satellite System, as well as the evaluated motion data of the train to determine an accurate location to the nearest centimeter. The HD map becomes the digital twin of the track and enables a continuous comparison of the target and actual position of the train in its environment. Sensor-based environmental perception also helps swiftly and reliably detect obstacles and hazards in real time, so that the train can be diverted and any necessary maintenance measures taken. As a result, the localization and environmental perception data of the train can be used for safe and efficient traffic management on the railway. The Sensors4Rail project harnesses the full potential of the digital rail system. Innovative sensors, highly automated driving, and intelligent controls become the new normal on the railway. The first milestones have already been achieved. However, this is just the beginning of the journey towards the digital rail transport of the future.
Okay, so that's, yeah, a great overview and definitely a fascinating project. So I think we have a few minutes before the train starts. So Ruben, can you maybe tell us a little bit more about in detail and explain the hardware and the software that is installed in this train?
Yeah, we started in 2018 with an analysis of the system requirements for our undertaking. And we came up together with our partners with this powerful sensor setup here. We can see the train front and the perception system that has multiple radars that you see in these red boxes. And that has 6 lidars in purple and has also 2 cameras in blue. And then we also have this real-time localization system that is now based on GNSS. So you see this Gnss antenna there. We have a high-performance server there and a 4G LTE antenna. And we have a wheel encoder. And all of this is connected to a data logger so that we can really collect data during our test rides. And then we have a redundant setup on the other side of the train so that our train can really go in both directions.
Okay, and Thomas, maybe can you tell us a bit more about what is so special about the digital map and maybe like how HERE is involved in this?
Of course, the map is a high-definition digital representation of the route that the train will be taking. The actual process of digitalization starts with the Lidar technology, which has been used to scan the area. Subsequently, an object recognition algorithm classifies the imagery into individual objects, such as buildings, stations, platforms, walls, and others. These are then transformed into the digital high-definition map. The reason we call it high definition is because it retains all the relevant details in 3 dimensions with centimeter precise positioning. This is the basis for the highly accurate localization of the front of the train. Now the map does not need to contain all of the objects along the route. The remaining ones are left unclassified and they are visible to the system as voxels. We will have a look at the voxel functionality later during this demonstration. Lastly, what I'd like to mention is that the HD map is stored on a server on board of the train. This means that even if there is no connection, the system can continue to function properly.
Thank you for this. And I think so we can see that the train is already starting. So in case you just jumped into the stream, so we're basically going to be following this Sensors4Rail train that is live in Hamburg at ITS. And basically everything that we'll be saying is what the train is perceiving. And just a bit of background info, we actually have some of our colleagues in this train right now. So we're literally spying on our colleagues right now. Thomas, maybe you can tell us a bit more now around landmark detection. So that's the first step that we see now.
Of course. Let me maybe just briefly introduce the control panels that are on the screen. The top panel is the route that the train is taking right now at the Hamburg S-Bahn. And we can see precisely where it is in between the stations. And then the left panel is showing which features are currently active. So we are starting with the landmark detection. Landmarks are elements of the existing infrastructure, such as posts, masts, walls, and the like. Every landmark is unique and registered on the high definition map. This main purpose of this functionality is to provide us with the centimeter precise positioning of the front of the train. Now, this functionality has been developed together with the project partner IBEO, and it is leveraging Lidar Sensors. The way it works is similar to radar technology, though instead of analyzing the reflection of emitted electromagnetic waves, Lidar sends out light impulses. The objects reflect the light, and based on the time it takes for the light to return, the distance and the angle of the object is calculated. This information is then used to match the landmark to those already registered on the high definition map. By combining the distance to several landmarks at the same time, we can further improve the accuracy of the positioning, though it is not necessary to detect all of the landmarks as the train is passing. In this demonstration, we can see that the landmarks that are recognized change their color to red. And we may also notice that there is a landmark detection counter in the left panel. So we can see that the train has so far encountered and detected around 260 landmarks. Later during the demonstration, we will see how the information from landmark detection is combined with the information from the other sensors. And now I would like to hand over to Ruben to tell us a bit more about the benefits about the train detection, actually.
Yeah, so switching from these static objects, we can also detect dynamic objects such as the trains. And when we encounter a train, we will show you this blue quadric that you see there in the picture-in-picture. And yeah, please mind this is live. So this computer graphics viewer you're seeing has a live data link to our live train. And so I can't predict for you when this is going to happen. So we will just see it when our train encounters really another train on the neighboring track there in Hamburg. The train detection function was developed by our partner Bosch based on radar, LiDAR, and camera data. That's a really important function. It's a core function for our future system. In railway operation, we often have to couple or also decouple trains. This is an operation that you can't just do with localization technology, but you actually have to observe where the other train is and in the scene basically measure the distance to that other train. Another reason, of course, is trains are obviously one of the most frequent other dynamic obstacles or objects, I should say, in the environment. And so it really helps for a digital system to understand what kind of object that is, so that we basically can reconfirm, okay, this object is not unknown, this is one of the digital trains. We have also localized, and so this makes it easier to interact in general.
Thank you very much for this. One thing that you can see as well at the very top is that we're following, like we'll see all the stations that the train is passing by. So we're slowly going to the next station. And for those of you who've been joining the stream, so this is live animation from the test train. So it's now approaching Midtjylland. Please excuse my French. What we see, so is what the train currently perceived. So Ruben, maybe like as Thomas explained, the landmark detection, and these are static objects. Is Sensors4Rail also able to detect dynamic objects?
We are able to detect dynamic objects, and in this demonstration, we've really focused on the core. And so we have also, for the dynamic objects, focusing just on the trains and the pedestrians, which are the most frequent ones we have in the railway system.
And now for the pedestrian, so maybe like we see there's different colors, like the green and the yellow. Maybe Thomas, like can you explain a bit like the meaning behind it?
Yes, of course. So the green color is for pedestrians that are at a safe distance from the edge of the platform, whereas the yellow color means that the pedestrian is too close to it. This functionality is based on the data from the Lidar sensors together with the imagery from the cameras. And as with the landmark detection, you may notice there is the pedestrian counter. And again, these are the real-time numbers of pedestrians that the train has encountered so far during this live demonstration.
And now I think we're heading to the track detection. Ruben, can you tell us a bit more about this part then?
Yeah, the track detection, that is a function that was developed by our partner Bosch for the live measurements. So they've implemented an AI that uses the camera data in order to predict where our headway is. And as you can see, there's a range depicted that shows us our current foresight with the sensor. So you can see this goes at up to 550 meters, which is the maximum range for the sensors that we have installed to the train. And this is complemented by map information. So obviously we also have a digital counterpart to the real track in our map. And this combination really allows us, first of all, to pull in as much foresight as we want via the digital map, but also to verify that our physical infrastructure is indeed in the state that we expect it to be. So as you may know, in railway, this is a really defined process, how to construct these tracks, how to maintain them. And so there's a lot of work going into that. And during our train rides, we're just verifying that everything is just in the state that we want it to be. And if it isn't, we have a trigger how we can more efficiently maintain it. So the track course, of course, is also interesting for the reactions. This is a relevant information in determining the risk. If there are any obstacles or objects close to our track or even on the track. And so we can really use this geometrical information to see whether we have to react to something that we did not expect to happen that way. Obviously, we can also do this for the neighboring tracks, but here we are focusing on our own track in this demonstration.
Thank you so much for this. And so far we've learned like how the train perceives its environment. Maybe Thomas can tell us how we can localize the train, and actually why do we even need this?
Mm-hmm. Yeah, so let me start with the how and then circle back to the why. So as we have seen in this live demonstration, we have several types of sensors on our train, and they operate in diverse ways. First, we have the Gnss Antenna, which is the global positioning system, and this one is working based on communication with satellites. Then we have the Lidar sensors and cameras that we have covered during the landmark detection and pedestrian detection. And additionally, we have equipped our train with radar technology. So this is the typical application of reflection of electromagnetic waves, and this is especially useful during reduced visibility conditions such as rain or fog. We also have a wheel encoder on board of the train, and this technology simply counts the amount of times a wheel has turned, and from that we can derive the distance that the train has traveled so far. All of this information is combined by the project partner Siemens into one consolidated position. You can see it as the green dot, and you can also see color-coded the positioning from the other sensors. Now we can see the precision of the consolidated position is 27 to 3 centimeters. So this is a highly accurate precision. And now coming back to the second part of your question as to why do we need the highly precise localization of the train? Well, if we know where the trains are exactly, we can have them running closer to each other, which means we can increase the capacity and utilization of railway tracks. And that we can do without building new infrastructure. And even if we would be willing to build new infrastructure, is not always possible, especially in the cities where real estate is scarce. And so it happens, it's the cities that are the bottlenecks in the networks today.
Okay, thank you so much for this. And I think we're slowly coming closer to the end of the train ride itself as we head to Tivstak station. And so I think the last functionality that is shown, and again, you can follow the steps on the left side, is the occupancy detection. It helps the train to recognize obstacles. And maybe, Ruben, you can tell us a bit more how it works.
Yeah, so in this picture-in-picture, you can see, or you have seen a red object that is supposed to picture a fallen tree on a neighboring track. And in general, as you've seen earlier, we have some objects where we have trained an AI specifically to detect the kind of object. So we've shown you the trains, we've shown you the pedestrians, the track. Those were all examples where we have an AI that was trained for specifically that detection task. Now, in an open environment, it can happen that we do encounter any unknown objects that we simply have never seen or that the system was never designed to deal with. And for that, we also need a functionality in order to deal with virtually anything. And another point is, of course, unstructured objects. So things like landslides, these things can only very hardly be described. And for that, we need a method, and that is the occupancy detection. So what we do is we span a grid in front of the train. You can think of it as the very small cubicles in front of the train virtually. And we use the Lidar measurements to measure whether these small cubes are occupied by anything. And this is what you see here with these small red cubes, where we can show you basically occupied small volume fragments. And that gives us some information. And this green tunnel that you see here, this is the clearance gauge. A clearance gauge is a thing that in railway we maintain to be free. So this is essentially provides like a virtual tunnel for the train to go through. And this is maintained by construction to be free of obstacle, but also through things like, for example, vegetation management that we do. And so, of course, there would be a side use also for this occupancy detection so that we can give some hints to the vegetation management. Once there's a tree growing into our clearance gauge, for example, we'd be able to detect that in this way. But the main use of course, is to have a way of dealing with any unknown objects that our train might encounter unexpectedly. This is our function, and that was developed by IBEO using the LiDAR scanner.
Thank you so much. And just a quick reminder that if you have any questions, feel free to ask them either on the YouTube chat or the LinkedIn chat, and we'll get back to you as soon as possible. And I think so now we can see like all the functionalities are switched on. So we can see, like all the different stations that the train has been passing by. We can see the different landmarks that we pass by, the numbers of trains and the pedestrians. If there's anything else, Ruben, that we're seeing here?
Yeah, so this is just generally the core set of functions I think that we need for a digital operation. And I hope you've paid some attention and you've seen the 4 trains that we encountered. Yeah, of course, this is not all of the functions we need, and we are looking forward to complete that picture in future projects. But for now, this is the core. What is really achieved here is with this real-time localization, we can work towards the goals of Digitalization, so increase our capacity using the same track network, but also increase the efficiency and the reliability of the system. And this is really emphasized also by the localization performance that you see here, but of course also by the perception functions that you've seen. And yeah, for all of this, you have also seen that the digital map plays a central role to complement the live sensors.
Thank you so much. And I think we're slowly getting to Berliner Tor, which is the last stop, which means this is almost the end of the live animation. So we hope that you enjoyed the virtual ride. So before I take some questions from the audience, I have a quick one for you, Thomas. So how does HERE contribute to this project, and why is the map so important?
So we have provided the mapping know-how and created the high-definition map of the route of the train. This is effectively the digital twin, which then allows us to digitalize the operations, but also to put in context all the data from the sensors that we have seen, like such as the landmark detection and so on.
Okay, I will take one quick question from LinkedIn. So I think we actually answered it, but just in case. So this is a question from Natalie. From how far do the sensors recognize objects on the tracks? I think you answered, but maybe you can still confirm.
Yeah, so we gave, I think, part of the answer. The sensors have a maximum range of 550 meters. That is a redundant field of view from the Lidar and the camera. We also have radar sensors that do not have quite that range. But the more precise answer is it also depends on the size of the object. So not all objects are visible at 550 meters. So it really depends on the size of the object. So for a human person, the detection distance is in order of 300 meters for an adult person. So to give you like an understanding of what the foresight is. And in general, this kind of coverage is fine for the S-Bahn operation.
And so Chris Socha is asking, what are the possible future use case of this technology? And I think it also goes to one question I wanted to ask you is, because this is a test project and this is a pilot that you're showcasing here at ITS, what do you think are the next steps for the Sensors4Rail project?
Yeah, I think the most important next step is to jump into the data collection. So I've mentioned before that multiple of those functions are based on AI and really complex AI models, and they are data hungry. And there was only let's say a finite amount of time during this demonstrator project to collect data. And we're really keen on using this working prototype to collect a lot more data, to get the functions more mature, and to develop some functionalities that really require also data because they are new. And that's what we're looking forward to. And it's going to take us some more time.
Then I guess it's a mix of a comment and question. So Karina on YouTube would like to see how this sensor and the real-time information can help and maybe communicate with cars or traffic lights to avoid long waiting times and car congestion at railway crossing. Is it something that could be done in the future?
That is something. I mean, we could share more information with the road traffic. There are some projects ongoing outside of Digitalization who are diving into this topic, but also requires some effort on the road users' systems. Because in the end, if you want to use this as a reliable signal, you got to make sure that it's safe, and for that, it would in principle be possible to do something like this. Yeah.
And another LinkedIn question from JF: what would be the benefits for the engineer and the NOC operator that this technology application afford?
Sorry, I didn't hear that.
What are the benefits for, I guess, like even for, let's say, for the driver? Do you think are the main benefit to have such technology on board?
Okay. Yeah, so for example, there are some benefits, of course, because the sensors, most of these sensors can see at night, for example. In the night, it's very difficult for a driver to see just about anything. But a Lidar sensor, a radar sensor, or an infrared camera, they can see at night just as well as during daylight. And that's a really crucial advantage. Other than that, I think drivers can also be supported with a function that doesn't get tired, for example.
Thank you. And so maybe Thomas, one for you then, it's coming from you again. So here is probably not necessarily often synonymous with rail. So how can here support rail companies?
Yeah. So as I mentioned before, the high definition map is a digital twin, and that is a trend that we can see in many industries. But specifically in railway, it unlocks a lot of potential for new use cases. We have seen about 25 opportunities where location intelligence can play a role in the railways, and that goes across the segments. So we've seen this one is useful for traffic management of railways, but we can also apply this to passengers, be it intermodal journeys, or if you would stop by our booth, you can also see 3D mapping of train stations, where you can use augmented reality for efficient wayfinding through train stations, which is especially useful if you're transferring in stations you have never been to. You can do a dry run from your home and make sure that you make the connection. Or we can also look into the freight segment, where we're looking into supply chain management and visibility, which is a requirement by shippers. So helping railways to provide and be part of these end-to-end supply chains and to fulfill the criteria as needed by shippers, and to optimize the operations and to contribute to sustainability and to reduce CO2 emissions.
And one question from LinkedIn again, from Alessandro Zulo. What benefits do you foresee for freight transportation?
Yeah, I think that's a big one, actually. Mainly because the freight operations, they're oftentimes, those are train rides that go very long distances. So sometimes these go cross country, between multiple countries, and sometimes require very special qualifications for the train drivers in order to be able to operate the trains between different countries. And then also with the extended length of these rides, this can be quite prohibitive. And I think this technology that we're developing can have a huge benefit to such rides, and really improve the efficiency a lot. And that I think that's very important. But the point is still we are still a little bit ahead. When we turn talking about when this is ready, this is still going to take us some more years.
Okay, thank you so much. And I think we'll probably stop here with the question. But if you have other questions, feel free to leave them in the chat, and we'll get back to you via message. So maybe the last quick one. So what can people expect from Dutch Bahn at ITS now that we're almost finished with, well, halfway through the event?
Yeah, so I mean, definitely pay a visit if you're at ITS to both of our demonstrators. So we have another demonstrator we haven't talked about today. There is a demonstrator that deals with automating the ride itself. So there is no track observation there done by any system, but it's just the ride itself, and that is a technology that you could expect to be rolled out rather soon, because it's ready for rollout, and it's homologated and it's available. And that is developed by Siemens and Deutsche Bahn, and you can definitely visit this automated ride. And if you're there, pay a visit to this prototype as well. In case the virtual experience wasn't good enough, you can definitely try the physical one.
Yeah, thank you very much. So if you would like to know more about the Sensors4Rail, we'll be adding more information in the chat box, in the chat. We're also going to have more on our social media channel, so stay tuned for this. If you are at ITS, just know that tomorrow we have another talk with Deutsche Bahn and Siemens Mobility. This will be tomorrow, 2 p.m. in the hall 3Z, and the room is Copenhagen. And we're going to be talking around how location technology is revolutionizing rail. And this is with one of your colleagues, Hanika Hundermarkt. And she will also be joining us at Here Directions, which is in October 20th and 21st. So if you miss this, feel free to see us online on the 20th and 21st. And again, make sure you're following our channel so you will know everything about this. And the last thing for ITS is that we are at the booth 310. We're actually very close from our colleagues at Deutsche Bahn. So we hope that you come to see us before Friday. And finally, for everything related to location technology, feel free to follow our social media channels, and I will see you in a future stream. Thank you very much for joining us.